All right, what I want to do in this lesson, or in at least this first segment of this lesson, is I want to explain an important concept, which I'm for now going to refer to as the fact that there are multiple solutions for sine and cosine, given that if you were told that sine and cosine were given a specific value. Okay, so let's just remember something. Remember that sine will always, the value of sine of theta will always fall between -1 and 1. You can never see, this is a false statement. If you saw something that said sine of theta is equal to 5, this cannot be true. It can't be true because we know that the values of sine are y values, and the highest value of sine is 1, and the lowest value of sine is -1, right? So sine can never, ever equal anything that is larger than 1 or smaller than -1. Now, note that I did not include or equal to, because if sine is equal to 1 or -1, then there are not, well, there can be multiple solutions, but they're not going to be on the same rotation. They're just going to be coterminal solutions, okay? And what I'm talking about here is that there are multiple solutions for sine and cosine, even just between 0 and 2 pi, or between 0 degrees and 360 degrees. So let's look at a quick example. Let's say that we had something that said sine of theta is equal to 0.38. Okay, well, remember that sine is a y value, so we're going to go to the y-axis, and if this is 0 and this is 1, 0.38 is probably somewhere around here. So let's say that this is 0.38. That is a y value of 0.38. Well, here's what I need to show you, right? Is on the unit circle, 0.38 exists in two places. It exists in the first quadrant, and it also exists in the second quadrant, okay? And so here's what I'm saying is, if I told you that sine was 0.38, there could be two angle solutions for this. We could have this angle right here. This angle would be a solution for theta, okay? But also, whatever goes over to here is a solution for theta. From here over to here is also a solution for theta. So we have two solutions for theta if we say that sine of theta is equal to 0.38, okay? And so as far as sine goes, if you have a solution in quadrant 1, then you will also have a solution in quadrant 2, okay? And the two solutions, what they're doing is they are reflecting over the y-axis, okay? These two solutions, these two angles, are at the 2 points that are reflecting across the y-axis, okay? Similarly, what if your example was sine of theta is -0.38, okay? Well, -0.38 is down here, -0.38, and we would have two solutions. One would be in quadrant 4, and the other one would be in quadrant 3. And so for sine, if you have a solution in quadrant 3, then you also have a solution in quadrant 4. Again, the solutions are reflecting over the y-axis, okay? So 4 is over here. On the other side of the y-axis is quadrant 3, okay? And, just if you want to think back to the unit circle with all the points, like up here at pi over 3, sine is square root of 3 over 2, and over here at 2 pi over 3, we also have sine as square root of 3 over 2, right? And then, of course, here cosine is -1/2, and over here cosine is 1/2, okay? And so I'm just clarifying, and I know we've seen this already, but I'm clarifying that there are two solutions for theta for any output value of sine. Same thing for cosine, okay? Let me move this back to 0.38. Let's say that cosine of theta, let me erase some of this right here. Let's say that cosine of theta is -0.7, okay? Well, Cosine is the x-axis, right? And so negative 7 is probably maybe right about over here, right? That's or 0.7, negative 0.7. And I also want to say, again, cosine is only going to fall between negative 1 and 1. So if you ever see something that says cosine of theta is equal to negative 17, that can't be true. Cosine only falls between negative 1 and 1. All of its solutions are between negative 1 and 1, okay? So let's say that cosine is negative 0.7. Okay, well, that's happening in two places. It's happening in quadrant 2, and it's also happening in quadrant 3. Okay, this point in quadrant 2 has an x value of negative 0.7, and this point in quadrant 3 also has an x value of negative 0.7. And so you're going to have two solutions that reflect over the x-axis, right, top and bottom. Okay, so if you have a solution in quadrant 2, then you also have a solution in quadrant 3. Okay? And then let's say that it was positive 0.7. Well, positive 0.7 is over here somewhere, positive 0.7. And if you have a solution in quadrant 1, then you also have a solution in quadrant 4, reflected over the x-axis. Okay? So if you have a solution in quadrant 1, you also have a solution in quadrant 4, okay? And so what I want to do now is I just want to show you how to get the other solution if you have one of the solutions. All right, so like we said before, at pi over 3, we know that the cosine is 1/2 and the sine is square root of 3 over 2. Well, cosine also is equal to positive 1/2 in the fourth quadrant down here, okay? And now we know that that angle measure around here, we already know that that angle measure is 5 pi over 3. All right, so here's the idea. Your basic rule is this, so to convert to second solution, okay? Here's how you're going to convert to your second solution is given your first solution, or let's say, basically, we're going to see how we can go from quadrant 2 to quadrant 3, and then how to go from quadrant 1 to quadrant 4. So if you have a solution in quadrant 2 to quadrant 3, or you're going from quadrant 1 to quadrant 4, okay? All you have to do is, for radians, you just have to do 2 pi minus the theta angle that well, let's just write solution in there. You're going to do 2 pi minus your solution, your first solution, okay? For radians. And then for degrees, you're just going to do 360 degrees minus whatever your solution angle is in degrees. For degrees. Okay, so let's show that this formula works. Well, we have pi over 3, so we have an angle in the first quadrant. And so to find the other one, we're just going to do 2 pi minus that solution to get our fourth quadrant. So we're going to go 2 pi minus pi over 3. I'm going to convert the 2 pi into 6 pi over 3 minus pi over 3. And that is equal to 6 pi minus pi is 5 pi. And 5 pi over 3, that gives me my solution angle in quadrant 4. Let's say we were going to do it in degrees. Let's say that we have an angle 135 degrees in, let's see, this angle right here is 135 degrees in quadrant 2. So to go to quadrant 3, I'm just going to do 360 minus 135. So 360 minus 135 is equal to 225 degrees, which is this angle right down here. Both of them have a cosine of negative square root of 2 over 2. This one is negative square root of 2 over 2. Okay, that's the cosine, right? That's the x-coordinate. And so that is how you find the other solution. Now, you can have additional solutions as well. You can do coterminal angles. So you can add 360 or subtract 360 to get to the next, the next way around, or the previous one around. But we already learned how to do coterminals, okay? All right, so what we're going to do now is I'm going to show you how to identify the other solution if you're dealing with sine. All right, so now it really depends with sine on whether you know the quadrant 1 angle and you're going to quadrant 2, or you know the quadrant 3 angle and you're going to quadrant 4, okay? And it has to do with the fact that you're reflecting over the y-axis instead of over the x-axis, okay? So let's say that you know the quadrant 1 angle, okay? And you want to know the quadrant 2 angle. Well, we know that on the unit circle, for example, the quadrant 1 angle of 30 degrees has a sine of 1/2. Well, sine also equals 1/2 over here, 1/2, okay, comma something, right? Something, comma 1/2 over here, but that's at 150 degrees. That's at a 150 degree angle. So we know that a 30 degree angle and a 150 degree angle will both give you the same sine value, okay? So a 30 degree angle or a pi over 6 angle, 30 degree angle, a pi over 6 angle should turn into a 5 pi over 6 angle, and a 30 degree angle should turn into a 150 degree angle. So let's see what kind of a rule would give us this, okay? Well, in terms of radians, the rule would go, basically you're just going to do pi minus the solution angle, let's see here, the quadrant 1 solution, okay? Or you can say 180 degrees minus the quadrant 1 solution. In fact, I'm going to come over here and edit this. Here we're going to say 2 pi minus the quadrant 2 solution, or the quadrant 1 solution. So quadrant 1 or quadrant 2 solution would be the same thing down here. 360 degrees minus the quadrant 2 or quadrant 1 solution will give you the quadrant 3 or the quadrant 4 solution. Okay, so if we did pi minus pi over 6, pi minus pi over 6 equals, well, let's turn pi into 6 pi over 6 minus pi over 6 gives us 5 pi over 6, and therefore this solution works, okay? All right, and now let's do it in degrees. 180 degrees minus our original solution was 30 degrees. 180 degrees minus 30 degrees is 150 degrees. And so if you're converting from the quadrant 1 to the quadrant 2 solution, these are the formulas that you're going to use. Okay, so we're going to say equals quadrant 2 solution equals quadrant 2 solution. Okay? All right? Now down here, going from quadrant 3 to quadrant 4, it's kind of weird, but I want you to understand this is going to work. Your two possibilities, your two formulas, one for radians and one for degrees. The degree one is 540 degrees minus. So we're going to do 540 degrees minus the quadrant 3 solution is going to give you the quadrant 4 solution. Okay? And so if we come over here, we know that, for example, that 225 degrees, we already saw this in the last one, that's going to be equal to a 315 degree solution. Okay? And so if we do 540 minus 225, minus 200 is 340, minus another 25 is 315. Okay? And so if you're given quadrant 3, just subtract it from 540, and that'll give you your quadrant 4 solution for sine. Okay? In radians, let's see, 3, 6, 4, 6, 5, so it's going to be 3 pi. 3 pi minus the quadrant 3 solution is going to give you the quadrant 4 solution. Okay? All right, so 225 here is the same thing as 5 pi over 4. Okay, so if we were to do 3 pi minus 5 pi over 4, all right, let's do this right here. 3 pi minus 5 pi over 4. We know the solution over here is 7 pi over 4. Well, 3 pi to be over 4 is going to be the same thing as 12 pi over 4 minus 5 pi over 4 gives us 7 pi over 4 because 12 minus 5 is 7. Okay? All right, so the reason that I'm going over this is because we are about to start working on the idea, we're going to work on solving trigonometric equations. And when you're solving trigonometric equations, oftentimes you're asked to identify solutions on a full circle. So if you're dealing in sine or cosine, you're always going to have two solutions. And so what I'm trying to help you understand is that if you have the quadrant 3 solution, you can get the quadrant 4 solution. If you have the quadrant 1 solution, you get the quadrant 2 solution. Now you can do these just with critical thinking. You don't have to use the formula, but I know many students oftentimes want to have some kind of a formula for getting their solution. Okay? What I'd like to do now is I'd like to use these rules and do a few problems over here where we identify the alternative solution given one particular solution. All right, so here's our question. It says if one solution for cosine of theta equals k, k is just representing a constant value, okay? The reason I'm not giving you a constant value is because I don't want you to just plug it in the calculator. I'm telling you that the solution to cosine of theta equals k is theta equals 73. Now we can find out what k is by keying in cosine of 73 degrees, but it really is irrelevant for this problem. The thing that we really care about is that one of the solutions is theta equals 73 degrees. We then want to know what is the other solution on the interval from 0 to 360. Since we're doing a full circle, we know that cosine will have two values of theta that are solutions. Okay? And so one of the solutions is 73 degrees. So we have to decide which quadrant is 73 degrees in. Well, 73 degrees is between 0 and 90, and that's in the first quadrant. Okay? So we know that the other solution is going to be in quadrant 4. It's going to reflect over the x-axis. And we know that for all cosine solutions, all we have to do is do, since we're in degrees here, all we have to do is do 360 minus 73. So 360 minus 73 degrees. Okay? And you can grab a calculator if you want to, but I know that this is going to be 287 degrees. And so the other solution is going to be 287 degrees. Okay? Let's try another one. Okay, so this one is actually a little tricky, okay? But I want to show you how you can still answer the question. It says if one solution for cosine of theta is equal to k, the solution is theta is 200 degrees, then what is the other solution on the interval from 0 to 360? So 200 degrees, we have to figure out which quadrant that is in. First quadrant goes from 0 to 90 degrees. Second one goes from 90 to 180. Third quadrant goes from 180 to 270. That's in the third quadrant. Okay? So the problem here is this, is that these formulas are for converting between from the first and second to the third and fourth, okay? In this case, we're given the third quadrant. We have to go back to the second quadrant. So what we're going to do is this. Since we're in degrees, we know that 360 minus the quadrant 2 solution, okay? 360 minus the quadrant 2 solution will give us the quadrant 3 solution. Well, we already know the quadrant 3 solution, okay? And so we know that 360 minus quadrant 2 will give us quadrant 3. Well, quadrant 3 is 200 degrees. Okay? And so now all we have to do is a little bit of algebra. We're going to add the measure for quadrant 2 to both sides. Quadrant 2, cancel. So now 360 is equal to 200 plus quadrant 2. Okay? Now subtract 200 from both sides. Minus 200, and we're going to get 160 is the quadrant 2 solution. Okay? And so our second solution is 160 degrees. So 160 degrees goes right along with 200 degrees in terms of cosine. Okay? All right, let's try a sine function. All right. This one's going to throw you off a little bit because I'm going to start introducing something that we haven't done yet in this class. Okay? It says if one solution for sine of theta is equal to k is theta is equal to 4 radians. Okay, now what does 4 radians mean? Okay, so it's not in pi. We're now representing radians in a value that does not include pi. Well, here's what I need you to understand. On a full circle, okay, we know that on a full circle, right, this is 0 radians, this is pi over 2 radians, this is pi radians, and this is 3 pi over 2. Well, if we convert these, and this is 2 pi, if we convert these radians out of pi, if we convert them into decimal values, what we get up here is about 1.57 radians. We know that this is about 3.14 radians. We know that this down here is, gosh, you know what, I'm going to get a calculator. You can always convert them just by grabbing a calculator. I should know this one, but I don't. 3 pi divided by 2 is 4.71 radians. 4.71, and we know that 2 pi is about 6.28 radians. Okay? So what we're doing here is this is, we're converting the radians from pi into a decimal value. And the reason we're doing that is because we're given a decimal value in the question. Well, where is 4 radians? 4 radians is between 3.14 and 4.71. So we know that 4 radians is somewhere on this interval in the third quadrant. This is the third quadrant. And therefore, since 4 radians, an angle measure of 4 radians, that would be starting here at the initial side. Here's the terminal side. This is 4 radians right there. It's in quadrant 3, so to get its other one, which is going to be in quadrant 4, we have to do 3 pi minus 4, which is the quadrant 3 angle. Well, 3 pi is 9.42 radians, so if we subtract 4 from that, we get 5.42 radians. And so 5.42 theta equals 5.42 radians. That is the other angle that goes along with the angle measure for 4 radians. And I need to tell you what we're going to do here is we're going to do all of these questions, instead of doing them in pi radians, we are going to do them in decimal value radians. So you really got to get used to this, okay? Let's do another example with sine and also with radians. All right, so we've got if one solution for sine of theta is equal to k is theta is equal to 2.1 radians, then what is the other solution? I should have changed this before, I'm sorry. In the previous example, what I should have had here is 2 pi and not degrees. I'm so sorry about that. Please, I'm sure I'll be ridiculed to the end of eternity by the math police, but I really don't care. I'll make a correction in the video. So what is the other solution on the interval where theta is between 0 and 2 pi? Okay. Well, where is 2.1 radians? We have to decide which quadrant 2.1 radians is in. Well, we know that the first quadrant is about 0 up to 1.57. Second quadrant is from 1.57 radians up to 3.14 radians, right? That's pi over 2 up to pi, right? Well, this is between 1.57 and 3.14. Therefore, this is in the second quadrant. So, second quadrant has another reflected solution over in quadrant 1. But this formula is for the second quadrant solution. So what we're going to do is we're going to take this pi minus quadrant 1 is equal to quadrant 2. All right, so pi minus quadrant 1 is equal to quadrant 2, right? Well, we have the quadrant 2 solution, which is 2.1 radians. So pi minus quadrant 1 is equal to 2.1 radians. And now what we can do is we can add quadrant 1 to both sides. Just doing a little bit of algebra here. Add quadrant 1 to both sides. Cancel on the left. And now we have pi is equal, well, let's rewrite it. Pi is equal to 2.1 plus the quadrant 1 angle. So now we're going to subtract 2.1 from both sides, and our quadrant 1 angle is going to be pi minus 2.1. So I'm going to key in pi. I'm literally hitting the pi button. Minus 2.1 gives me 1.04. So 1.04 radians, and that is my quadrant 1 angle. So 2.1 radians goes along with 1.04 radians, okay? All right, so there's a few examples. What I'm going to do now is I'm going to give you, some problems on a worksheet, and then also in the practice quiz, you'll be able to practice lots of problems just like this so that you can get used to understanding the two solutions between cosine and sine. Okay?